How's it going, everybody? And whoa, one second while I adjust my sound so I don't blow your eardrums out. There we go. We're going to be taking a look at welcome back to our Cisco Enterprise series, where we're going to be focusing on OSPF authentication in this video. So we're going to take a look at the couple different variations of OSPF authentication that are available to us. We're going to be dealing with just OSPF version 2 in this video, and when we get to the IPv6 section, which is when we cover all the major topics and stuff like that, we'll deal with OSPF v3, where you can include encryption as one of your options. So the capabilities of OSPF when it comes to authentication vary depending on what you're trying to accomplish. So you have link level encryption, or I'm sorry, link level authentication, and then you have area level authentication. So just as a quick side note, and let me hit the log back in. When we look at our topology, right now we are looking at, as soon as it wants to load, we are looking at OSPF in this little topology right here. Okay, now as it sits right now, the way that I've recorded these videos, I have EIGRP fully deployed over here, and I'm about to go flip that over to OSPF to take a look at OSPF in more detail. But what I want you guys to focus on right here is how OSPF right now, configuration-wise, is base deployment, right? Where we have just a bunch of I can't talk, a bunch of adjacencies turned up, and everything's operational. So what we're going to go do is cover what authentication does and how it works, and then we're going to go take a look at a couple of examples of how authentication can be done. So, supports authentication to protect control plane, prevents against routing injection attacks. So the OSPF packet header includes authentication format, the hello, link state update, and link state router. Or I'm sorry, link state request. Authentication does not mean encryption. So if you hear the term routing protocol authentication, whether it's EIGRP, OSPF, ISIS, BGP, or RIP, what it means is you are basically setting a password that needs to match on both ends of the adjacency. So when it comes to authentication, we mean authentication and not encryption. So the version 2, OSPF version 2 payload is clear text, where the OSPF v3 has optional support for encryption. So it's a one-hop IPsec tunnel with ESP, the encrypting security payload, or AH, or the authentication header. So this actually is just really strong authentication. This right here is actually encryption. So OSPF supports 3 different types of authentication. You have no authentication, or null, 0, type 0. You have clear text, which is just a simple password. And then we have a hashed password, so MD5 or SHA. So when we go through and configure our demonstration here in just a moment, what you're going to end up seeing is a combination of both. And we'll do one clear text and we'll do one hashed. Now, if you were to Wireshark capture the clear text, you would literally see the password in clear text. Where if you were to, because you're not passing that password through an MD5 hash, getting an output, and then handing that, passing that hash password over to the other router to exchange. So you never actually send the password in clear text. You send the hash of the password between the routers, and then when they receive it, they're able to discern what that password is based off of the hashing. So, because a lot of people are like, well, if the hashes are different, how does it know the password's the same? It's like, it just knows. Like, there's a how it actually does it, I really don't know, but at the end of the day, it really doesn't matter. So there's a couple different ways that you can turn on authentication. You have the OSPF process level, then you have the link level. The link level overrides the process level, and key is always applied at the link level. So if you're going to do at the process level, you're going to be doing it basically at the area level. So you, is it? it's process level. So you would say IP OSPF, or was it Area 0 authentication, something or other, something like that. And then if you are going to do it at the link level, it would be like IP OSPF authentication mode MD5, something along those lines. I don't remember the exact syntax on the top of my head, but I can, within just a couple of moments, figure out what it is. The key numbers must match on both sides in order for this to work, and the lowest active key is used. Can be enabled if under the process all links in the process are authenticated. If enabled under the interface, only that interface gets it. On all links in the area on a per link basis. So there's a couple different ways that you can implement it. Now there is this concept, and I'm debating whether or not to talk about it. Actually, let me jump over here to the CCIE blueprint and scroll down to OSPF. So there's no specific call out for a virtual link, but it is one of the options that's available for authentication is the virtual link. A virtual link, since it's literally right there, what you end up getting with a virtual link is a control plane extension where if you remember what I talked about in a previous video when it comes to areas and stuff like that, where area 0 is your backbone. So a quick example of this would basically mean this. If I have area 0, and then I have area 1, then I have area 2, and I have 3 and 4, and they all connect back to area 0. Well, this is a valid design because the fact that all areas connect to area 0, so I'll just draw a line here just for simplicity. They all connect to area 0 somehow through an area border router, and everybody's happy. This is a valid design. So now, if I was to take and then have attached to area 4, I did, 5, or I did 6. Is this a valid design? No, it is not. So in order to make it valid, I would have to create a virtual link from the area border on area 0 that connects to area 4, and then for the router that borders area 4 and area 6. What you would essentially be doing is you'd be extending the control plane down to this ABR. And it's a control plane extension. And what it does is it allows area 0 communication to happen to area 6. Or whatever other area you're using. It's a discontiguous area design. It is not a valid design. So if you have a situation like this come up where you have to create a virtual link between your area border router of area 0 and area 4, and then on the area border router for area 4 and 6, if you have to do this, that means you did something wrong somewhere else, and you need to reassess what you've got going on. Now, truth be told, is I remember being in an interview where this question came up. Somebody started drawing something on a whiteboard, and as soon as I saw it, I go, okay, you needed a virtual link between that router and that router, or else it won't work. And the guy, I'll never forget the guy. He looked over his shoulder at me because I was sitting on the other side of a table, and he goes, "Okay, got it." He looked at the other two people that were on the either side of the table from me. So I was sitting, it was a long conference room table. I was sitting on the opposite side of the room from him, opposite the whiteboard. There was a guy to my right, and there was a guy to my left. And he had questions on that, and the guy goes, "No, he's right." So he immediately grabbed his eraser and started erasing the board and started going on to his next topic of discussion. What the interview actually turned out to be was a stump the chump interview. How much did I actually know? I sat there for an hour and a half digging into how OSPF works, because that was the only protocol they ran besides BGP, and the BGP that they had was simply just a BGP peer into the outside world, simple MPLS VPN, and then they did redistribution between OSPF and BGP. Everything else, these guys really liked OSPF. So for me, I had to know OSPF pretty well, and I was eventually offered the position. After an hour, it was an hour and a half, and it was actually kind of funny because when I got done with the interview, I walked out, and I jokingly said to the three guys, or I jokingly said as I was walking out of the conference room, I said, I feel like you guys opened up the configuration guide for the latest version of OSPF on the latest version of code, and we're like, we're just going to grab something from everything and see what he knows. And the one guy goes, that's pretty much what we did. He's like, you're coming in here as an IE, we're going to want to see what you actually legitimately know. I was like, fair enough. So I was offered the position, but I respectfully turned it down because A, I don't want to work for people that are going to sit there and try to pick apart my knowledge base. So I don't want to sit there and go off on a tangent, but a lot of the questions that I was getting was, how much of the configuration guide did I read? So not really relevant to this, but it was virtual links, and I had to, like, when he drew this out, I go, oh, you need a virtual link. And he was just like, oh, okay. I'm not going to go much more into how OSPF works with virtual links, at least in this video. I will probably go through and do a variation of that at some point in later on, and how a virtual link would come into play. But for right now, just remember that if you are going to be working with discontiguous areas, so you have an area that uses another area that is not area 0, so area 1 through 4.2 billion, and that connects back to area 0, that is not a valid design. So keep that in the back of your mind. So that's basically how that works. So I'm going to go ahead and clear the screen. I'm going to go ahead and we're going to go ahead and do a basic OSPF authentication implementation here, and we're going to go ahead and knock that out real quick. It shouldn't take us too long to go through that. I'm not going to spend a ton of time digging into authentication, but at least show you guys a basic example of it. So where is 26? 26 is way over there. How that happens is beyond me. Okay, so what we're going to do is on R26 and R27, I'm going to do a basic example of clear text authentication. So I'm going to go down to interface gig 0/0. I'm going to type in IP, OSPF, and then it's going to be, there's a lot of options. I'm going to type in authentication and then -key, and it's going to be actually I need to type in authentication, and then I'm going to hit the enter key, and then I need -key, and the key is going to be Cisco. Simple as that. And then I'm going to go over to 27, and I'm going to do a debug IP OSPF hello and adjacency. And then I'm going to go to global config, and we should see some traffic. Okay, so right here is what I wanted you guys to see. Receive packet from 126.27.26, mismatched authentication type, input packet specify type 1. We use type 0. Remember what type 0 is. That means what? That means no authentication. So what I'm going to go do is I'm going to go to interface gig 0/0. I'm going to type in IP OSPF authentication, and then the key is going to be Cisco. So we should be able to send there it goes, and now it's working again. Now, if we were to go back to 26 and do a show IP OSPF interfaces gig 0/0 detail, if we look here, we will see on gig 0/0 simple password authentication enabled. If somebody was to give you an output of this configuration, there you go. It's not a adjacent, so there's not to the adjacency. So show IP OSPF neighbor for detail, right? It's not going to tell you here that there's any type of authentication going on here. It's an interface level configuration. So I'm going to go ahead and do the exact same thing for, I'll go to interface gig 0/1 and do the exact same thing. So I'll do this, and then I'll go over to XR42, just so we can see it on XR. We're going to go to router OSPF 1, area 0, interface gig 00001, and then we're going to specify authentication, and then authentication dash key is going to be Cisco. I'm going to commit that config, and then if we go back over here to 26, do show IP OSPF interface gig 0/1, we can see simple password authentication is in use there. It might take it a couple of seconds for it to trigger. Oh, show config failed. Show config failed. It says that interface already exists in... Oh, so do show run router OSPF. Okay, that's my mistake. So I'm going to type in, I'll go to root, I'll jump out of global config. And if you have candidate configuration in iOS XR and you jump out of global config, it's going to ask you if you want to commit. I'm going to say no, and then it's going to let me drop out. So it's going to throw away the config. I'm going to go to router, actually I'll just go down to here. Go to here, I'll type in authentication, and then authentication key is Cisco, and commit that. And then as soon as it does, it should bring up the adjacency again. There it goes. And we can see that it's enabled, everybody's happy. And if I go to XR42 and I do show OSPF interface gig, and hit the enter key, we're going to see right here, clear text authentication enabled. Simple stuff, right? Nothing very complicated to deal with. All right, so now that I've shown you clear text, let's go ahead and take a look at a hash password on 27 and 60. So on 27, I'm going to go here, and I'm going to go to interface gig 0/1. Let me start on 60, because there's less going on 60. Let me flip these two around. So I'm going to go to global config, interface gig 2. I'm going to type in IP OSPF, and then it's going to be authentication, but I need to specify that it's going to be message digest. Message digest. And when I do message digest, I'm going to hit the enter key, I'm going to hit the up arrow, I'm going to back all that out, and then I'm going to use the message digest key. Key ID is going to be 1, and then it's going to use the MD5 algorithm, and then what's the password going to be? So Cisco. So IP OSPF message digest key 1 MD5 Cisco. Hit the enter key, and then do show interface. Do show IP OSPF interface gig 2. We can see that now it's got cryptographic authentication enabled. Youngest key ID is 1. So I'm going to do the exact same thing on 27. So 27 is probably freaking out. Here it goes. It says mismatched authentication type. Input packet specified type 2. We use type 0. So I'm just going to go to interface gig 0/1, type in IP OSPF authentication message digest, and then message digest key is going to be key 1, MD5, and then Cisco. And then as soon as it goes back and forth, and this one says, and there it's loading, send it with key 1. This one's, I'm not grabbing it quickly enough. Probably would be faster and more smart if I was just to turn. Okay, so do undebug all. If you look right here, it says receive packet from 127.60.60, so R60, mismatched authentication key, invalid cryptographic authentication key ID 1 on interface. No valid authentication send key is available on interface gig 01. So it's telling you essentially we detect cryptographic authentication at MD5 hash, but we don't have anything configured on our side. That's the problem. So if you were to look at the debugs and a quick, they're not doing anything fancy with the debug. So if you're not exactly sure what the problem is, you can always throw a quick debug on, especially OSPF. I think OSPF has better debugging outputs than EIGRP does. That's just my take on it, which is one of the reasons why I like OSPF more than EIGRP. But as you can see, it gives you some output as to what's going on. So that is going to be OSPF link level authentication. So we're going to do a quick demonstration of interface level authentication as well, or sorry, area level or process level. So I'm going to start on 26. I'm going to hit the up arrow and type in no IP OSPF authentication. I'm going to go ahead and key Cisco. I'm going to go and type in no there. Or gig 0/0 as well. Just do a quick turn off. Knock that out. Okay. And then on 60 as well. And right there. And then on 42, do the same thing. So I'm just going to type in no authentication, key Cisco, and commit that, just so we're not trying to troubleshoot two different problems. I'm going to start on 26, which is right here. And I'm going to go to router OSPF, do show IP OSPF. So router OSPF 1, just do show run section OSPF, just to make sure. Router OSPF 1, and we're going to type in area 0, and we have authentication, and then message digest. So you can do clear text here as well, if you wanted to do that, but actually take that back. No, you could type in authentication. So you can specify the level of authentication at the area level. You define the password at the link level. So that's why I'm not showing you how to do area level authentication over on the bigger topology. I'm not showing you authentication here because there's a lot more moving parts. There's more devices. I'm showing you how to do that here where there's only a handful of devices. It makes it easier for me to implement, and I don't have to worry about as much detail. So if you're going to do it on a grand scale, you could do it at the area level, and then that's what they call the process level. It's actually the area level. And then go to the interface level and define the password. So I prefer, like if I'm going to do this, I'm going to type in message digest because I'm just going to do type 2 authentication out of the gate. But if I do this, then I have to go to interface range, gig 0/0 through 1, and type in IP OSPF a message digest key 1 is going to be Cisco. Key 1 MD5 is Cisco. Okay. Now I have to repeat this process on all the other routers. So let's go ahead and knock that out. On 27, I'm going to do the exact same thing. Type in router OSPF 1 area 0 authentication message digest interface range gig 0/0 through 1 IP OSPF authentication. I'm sorry, message digest key 1 MD5 is going to be Cisco. So we're going to wait just a moment for that to happen because that should allow me to form a peering with 26. Now, if you're seeing some BGP stuff, flap. Like I've mentioned a few times in this video series so far, I am not I'm not recording these videos in linear fashion. I'm not doing all of OSPF, then all of EIGRP, then all of BGP. I'm doing them in chunks. So that's essentially how that comes into play. So I will be bouncing around just so that I can, as I'm demonstrating a particular capability, I've already got the majority of the infrastructure stood up. So did that. That's 27. So why is that not triggering? 42, do show IP OSPF neighbor. That's weird. Do show IP OSPF interface gig 0/0. It should have already formed an adjacency. Let's just double check on 27. Do show run section OSPF. Okay, that looks correct. So, oh, that's because it's still got do show run interface gig 0/0. That's how I've got competing. Okay, so I'm actually glad this happened. I've got competing types here. I've got type 1 and I've got type 2. You can't have both. It's one or the other. So I'm going to go ahead and pull out this, and the adjacency forms right away. So now if I go back over to 26, I have my neighbor already good to go, so that my BGP peering that I've got running over that would come online. So let me go over to 60, and BGP should have one. Do show IP BGP sum. Yeah, my peering to 27 is back. That's been back. So we're good to go there. So I'm going to go ahead and jump over to 60 and get 60 configured. And I'm going to type in router OSPF 1. Type in area 0 authentication message digest, and interface range gig 1 through 2, IP OSPF message digest key 1 MD5, and Cisco. And then I get to go jump over to 42, and then I get to jump out go to here, and I get to say authentication message digest, and hit the enter key. And then I got to go to interface gig 00000, and then the message digest key 1 MD5 is Cisco, and repeat that for gig 1 as well. Show config. So we're enabling it at the area level and then specifying the authentication at the link level. I'm going to go ahead and commit that, and we'll be in good shape there momentarily once the process comes back online. So I've got my peering to 26 and to 60 back as soon as authentication passes. Then my BGP neighbors come back online. Perfect. So that brings up a question. When do you run into problems with BGP with this? Or you know, why are we seeing BGP problems? And the simple answer to that is, well, that goes back to a conversation that I had when we were, well, at least I was discussing it when I was recording the BGP videos for that for full mesh iBGP, when you're doing loopback to loopback peering, it's assumed that the IGP is stable. So layer 2 is good to go, layer 3 is good to go from an OSPF perspective, and then you have BGP riding over the top of that. So BGP relies on IGP for a loop-free topology. So your IGP needs to be fully converged and fully stable before your BGP peerings are going to start to do what they need to do. So if you have any issues in your underlay is going to be the IGP that BGP is using in order to communicate from loopback to loopback. If there's any issues with that, that's going to be a problem. So your IGP's got to be locked in solid before you start monkeying around with BGP. So if you see BGP flapping, don't automatically think there's a configuration issue with BGP. There could be a transport layer issue with BGP. So the one thing to keep in the back of your mind as well. But that really brings us to the end of what I want to talk about in this video. We're going to take this a little bit further as we get down the road, but as we get further along, this is what I really want you guys to understand. So that is OSPF authentication in a nutshell. Pretty straightforward stuff, but it definitely needs to be understood. So if you guys have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.